Up to today's lecture in MT 5504 Mathematical Programming's Unit 4 in Transportation Problem, we have seen that how to reach to the optimal solution via stepping stone method. But in stepping stone method, you know that it is having a long way means you have to identify that what is the allocation, then find out each and every possible loop for non-allocated cells, and then you are planning from where you have to transport, and then again go back to the first situation that find out possible loops and so on. So that is a very difficult task. So instead of that, we will see today a MODI method, MODI, modified distribution method, which will help us to reduce the process of what we are using till now. What is that? Let's see. Here, I am posing one problem. Problem is here as given in this situation. It is quite similar to the situation we have used in the previous problem. And here we are having three sources from where we have to transport to destinations D1, D2, D3 and D4. Here transportation cost is already given. Now we want to first of all find out this solution, which is initial basic feasible solution via northwest corner method. Okay, and then we will first of all we will apply the northwest corner method. Then we will go for stepping stone method to reach to the optimal solution. That is one way, but then we will replace stepping stone method by MODI method, modified distribution method, and then using this we will reach to the optimal solution. Okay, so first of all apply northwest corner method. So here minimum of 400 and 700, that is 400, so we will transport 400 units from this. So here we are left with 0 and here we are left with 300 units. Now our northwest corner is this. Here minimum 450 and 300 is 300. So we will allocate 300 units here. Here we are left with 0. Here we are left with 150 units. So our northwest corner is this. So minimum of 150 and 400 is 150. So here we will allocate 150. Here we are left with 0. Here we are left with 250 units. Then this is our northwest corner. So here we will allocate whatever is maximum that is possible, that is from 250 and 350 it's maximum. It is sorry minimum, that is 250. So here we will allocate 250. Here we are left with 100 units. Here we are left with 0 unit. Then our northwest corner is this one. Then so here we are having 100 and 600. So minimum is 100. So we will allocate 100 units here. Here now we are left with 0 and here we are left with 50, 500 units. Now only one cell is left, so we will allocate whatever is left, that is 500 units. This is our initial basic feasible solution. Okay, now we will apply the stepping stone method to find out the way to reach to the optimal solution. For that, I will copy this table So only I want the allocations. Okay, so that's why I have just copied the allocated table. Now, at each and every point where is allocation is not done, for that we have to identify the additional transportation cost. So I am starting from the first point, that is this one. What is the here? Let me recall this are ABC and these are D1, D2, D3 and D4. So first of all, to find out allocation, maximum allocation possible from D3 and at corresponding additional transportation cost, here I am having a loop like this. A to D3 from AD3 to BD3, then BD2, then AD2, and then come back to AD3. So I am writing the additional transportation cost on transporting via that point is A to D2, sorry, A to D3. From there, we will go to B to D3. From there, we will go to B to D3, B to D2, and then A to D2, and come back to A to D3. As I have already shown, this is a loop. Okay, so the additional transportation cost is here. If we form this as a loop, then we keep here plus, here we keep minus, here plus and minus. So this will be added 8 minus 2 plus 3 minus 9. 8 minus 2 plus 3 minus 9. So it is 6 minus 6. So it is 0. So here additional transportation cost is 0. Now at this point, so I am directly writing, that is A to D4. From there, now if we are adding something here, then we have to subtract something here. So that is C D4. From there we will go to C D3. From there only possibility is go to B D3. From there we can go to B D2. From there we can go to A D2 and then come back to A D4. So additional transportation cost. Let me draw a loop so you can get it. Okay. Here, 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 and come back. So additional transportation cost is 6 minus 6 plus 3 minus 2 plus 3 minus 9. It is 6 minus 6 plus 3 minus 2 plus 3 minus 9. So that is 6 minus 6 is 0, 3 minus 2 it is minus 1, sorry, plus 1, and here it is minus 6. So it is minus 5. So here additional transportation cost is minus 5. Now continue this way. If I want to transport from this point, then B to D1, sorry, BD1, I am directly writing BD1. Then my loop is from here to here, 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 and come back. That is BD1 to BD2, BD2 to AD2, AD2 to AD1, and then come back. So in that case, additional transportation cost is here, that is plus, so plus 4 minus 3 plus 9 minus 3. So it is minus 6, 9, so 3, 4 plus 3, it is 7. So here additional transportation cost is 7. Now find out the additional transportation cost for B to D4. So B to D4 if you want to transport, then we have to subtract from C to D4. So C to D4, from there C to D3, then B to D3, and then come back. Okay, in that case, your additional transportation cost is, at here it will be plus, then the next is minus, so 1 minus 6 plus is 3 minus 2. So here you are having 3 plus 1, that is 4, minus 6, it is minus 2 minus minus 2, so it is minus 4. So here additional transportation cost is minus 4. Now for this point, C to D1 if you want to transport, then from this only possibility is to go to AD1. So I am taking for AD1 to only possibility is to go for AD2, AD2 to BD2, BD2 to BD3, BD3 to CD3, and CD3 to come back to CD1. In that case, additional transportation cost is 9 minus 3 plus 9 minus 3 plus 2 minus 3. So it is, if you could not go the loop, then let me draw you this, then back. Here plus 9 minus 3 plus 9 minus 3 plus 2 minus 3. Okay, so that is the answer. So here my additional transportation cost is 9 minus 3, it is 6, 9 minus 3, it is 6, and here it is minus 1, so it is minus 11. So here additional transportation cost is, oh sorry, it is 11, not it is minus 11. 6, 6 and 11, minus 1, so it is 11, not minus. Okay, now for this point, additional transportation cost, that is from C to D2, CD2. From there we can go to BD2, BD2 to BD3, BD3 to CD3, CD3, yes, and then come to CD2 back. So that additional transportation cost is 4 minus 3 plus 2 minus 3. So it is 4 plus 2, it is 6, minus 3, it is minus 6. So 6 minus 6 is 0. So here additional transportation cost is 0. So this method is called stepping stone method, and then we will continue with this minus 4 and reach to the optimal solution via transporting from A to D4 what is the maximal possible. Okay, but don't you think that this is too much lengthy process to find out each and every additional transportation cost? Okay, yes. In that case, we will have another method, that is modified distribution method, which will help you to identify this additional transportation cost directly. Okay, so here is the table. I am temporarily removing this. Okay, so you can recollect that we have reached to the direct solution. Okay, so in this method, all we are doing is taking here variables u1, u2, u3, u4. Here variables v1, v2, and v3 in a way that for allocated cells, ui plus vj is the Cij, that is transportation cost. So here, say for example, u3 plus v2 must be 2 in that way. So if you think about here, so here it is you are having 1, 2, 3, 4, 5, 6, 7 variables, and allocated cells 1, 2, 3, 4, 5, and 6. So you are having actually 6 constraints. So if you are having 6 constraints in 7 variables and all are linear equations, so you know that it will have multiple solutions. So take any one of the variable as 0. Simply I am taking u1 to be 0. In that case, see u1 is 0 and you know that v1 plus u1 is 3. So you must have to take v1 is equals to 3. Now take since v1 is equals to 3 and here u2 plus v1 is equals to 9, you have to take this as equals to 6. If you want to make u2 plus v2 3 and here you are having 6, so you must have to take v2 is equals to minus 3. Since v2 is equals to minus 3 and v2 plus u3 is equals to 2, you must have to take v3 u3 is equals to 5. Then only 5 plus minus 3 is equals to 2. Then since v3 plus u3 is equals to 3, you have to take, this is already 5, so you have to take here minus 2. Since v3 plus u4 is equals to 6, v3 plus minus 2 it must be 6, so here you have to take 8. Now your additional transportation cost is corresponding dead cells transportation cost minus sum of these two, that is 8 minus 3 plus 5, that is 8. So 8 minus 8 it is 0. Here you are having 6. 6 minus 3 plus 5, 3 plus 8. 3 plus 8 is 11. So 6 minus 11, that is minus 5. Here you are having value 4. So 4 minus minus 3 plus 0. So 4 plus 3, it is 7. Here you are having value 1. So 1 minus minus 3 plus 8, that is 5. So 1 minus 5, that is minus 4. Here you are having 9. So 9 minus minus 2 plus 0. So 9 minus minus 2, it is 11. Here you are having 4. So 4 minus 6 minus 2. 6 minus 2 is 4. So 4 minus 4, it is 0. See, previously we were having transportation cost 0, minus 5, minus 4. Here also we are getting 0, minus 5, minus 4. Here we were having 7, 11 and 0. Here also we were having 7, 11 and 0. So this method is called Modi method. Modi is just for modified distribution method. Okay. Okay. Here all we have done is taken this quantity initially directly with 0. u1 I have taken 0. Instead of that, if you have started with the case another variable be 0, let me do that also so you can get that yes, the choice of which ui or vj is 0 is independent. So let me take another variable be 0. So here you are having u1, u2, u3, u4, v1, v2 and v3. You want u1 instead of u1 something else be 0. So let u3 be 0. So if u3 is 0, you want u3 plus v2 be 2. So here your v2 must be 2. If that is 2, again here u3 is 0, so your v3 must be also 3 because you want to sum that here 3. Since this is v3 is 3, your u4 must be 3 because u4 plus v3 is equals to 6. Then here this v2 is 2 and here this sum is 3. So here this quantity must be 1 because their sum is 3. If this is 1, then 1 minus v1 is must be 8 because this 8 plus 1 must be 9. And since this is 8, and to make this quantity 3, we must have to have this quantity minus 5. Okay. So now all we have to do is find out the additional transportation cost via the same process. So that is 8 minus sum of these two, that is 8 plus 0. So it is 8 plus 0 is 8. 8 minus 8 is 0. Here 6. So 6 minus 3 plus 8, that is 11. So 11, 6 minus 11, that is minus 5. Here it is 1. So 2 plus 3, that is 5. 1 minus 5, it is minus 4. Here it is 4. Here this term, minus 5 plus 2, it is minus 3. 4 minus minus 3, it is 7. Here it is 9. 3 minus 5. So 3 minus 5 is minus 2. 9 minus minus 2, it is 11. 9, 4, 3 plus 1, 4. 4 minus 4, so it is 0. So see here you are getting the same values, okay? Additional transportation cost is same. Why it is so? Only because in each and every UI you have subtracted minus 5, see clearly. And in each and every VI you have added 5. So when you will get UI plus VJ, their sum will be same to get CIJ. Because here you have added 5 and here you have subtracted 5. Sorry, here you have subtracted 5 and here you have added 5. So in all cases, the Cij minus Uy plus Vj will be same. Okay, so that is the reason why the choice of Ui Vj will not be deferred. The additional transportation cost. Okay, now one more thing I want to add in this situation, that when you are getting the negative values, in stepping stone method you just have starting with the situation that just transport whatever maximum is possible from this point. That's okay. But we think one more step forward, that for both the cases, first of all, find out the loop. So here, my loop will be from here to here, 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 and come back. So what are the positive corners? So my positive corners are, here it will be positive, here it will be negative, here it will be positive, here it is negative, here it is positive, and here it will be negative. From negative corners, the minimum is 250. So here we will have difference is minus 5 times 250. So this much will be reduced in transportation. Instead of that, if I go for this cell, then the transportation will be in this way. Here, what are the positive cells? This and this. What are the negative cells? 250 and 500. So, what is the additional transportation cost which is going to be reduced? That is, minimum is 250. So, 250 times 4, and that is with minus sign. So, what is the maximum possibility here? That is for this one. So in here we will transport from this point. Okay. If you are getting more values even for 4 instead of 250, if we were having 500, then we may choose this point. Okay. But here we are getting for this one. So we are starting with that point. So now all I have to find out for this loop. Here we are having these positive corners, and the negative corners are this, this, and this. So minimum is from negative corner it is 250. So we will reduce 250 at the negative corners and add 250 at the positive corners. So the next allocation, here there is no change, so it is 400 as it is. Here we are having 350 minus 250. So here we are left with 50 units. Then here we have added 150 250. So here we will have 250. Here 150 plus 250. So it is 400. Here 250 is removed, so it will no more be there. Here we are having 100 plus 250, so here it will be 350. And here 500 minus 250, so it is 250. Okay, so this is our next allocation cell. See clearly again, previously it was here sum was 450. Again here we are having sum 450. Here previously sum was 350. Here also sum is 350. Here it was 500. So here also sum is the 500. All if you go for rows, also you are getting the same situation. Okay, now we will go for identifying UI and Vj. So let U1, U2, U3, U4, V1, V2, V3. You can take anyone to be 0. So I am taking this V3 be 0. Okay, so here U3 is 3, U4 is 6 because their sum is corresponding 3 and 6. Since this is 6, here it is already 6, so your V1 must be 0. If that is 0, your U1 must be 3 and U2 must be 9 because the corresponding sums are 3 and 9. Now, since this is 3, here it is 9, so your V2 must be minus 6. And in this, now all UI and VJs are known. Now, we start to find out the values of the additional transportation cost. That is 8 minus 0 plus 3. So it is 8 minus 0 plus 3 is 3. So 8 minus 3 it is 5. So here additional transportation cost is 5. Here 2. So 2 minus 6 plus 3. So minus 6 plus 3 is minus 3. 2 minus 3. So it is 5. 1 minus 6 minus plus 6 minus plus 6. So minus 6 plus 6 is 0. So 1 so it is 1. Here minus 6 plus 3. So it is minus 3. 4 minus 3 it is 7. Here it is 9 minus sum of these two, that is 3. So 9 minus 3, so it is 6. Here it is 4. So 9 0 plus 9, so it is 9. So 4 minus 9, so it is minus 5. So here you are getting the negative value. So we will find out the loop so that we can reduce the transportation cost. Okay, so from here we are having here, then come back to here, then here, and come back. What are the positive corners? So this and this is your positive corner. And what are the negative corners? So this and this is your negative corner. So our next table is all the other remained. I am copying as it is, and in that case here 400 as it is, so 400. Here negative corners are 50 and 250. So minimum is 50. So we will allocate 50 here. So here it will be 50. This will be reduced 50. So here it will be 0. So I will not write there. Here 50 is added. So here I am having 300 units. Then since here 50 is added, we have to subtract 50 here. So here we are left with 200 units. And then here 350 is already as it is. Now it is not going to be changed, and 400 is as it is because it is also not going to be changed. Again, you will see that this is a correct form. Means sum of 400 and 300, it is 800 as previous. Sum of this is 450 is 450. Here also 350. Here it is also 500. So it is continued in that fashion. Now all we have to do is find out ui and vj's. So here u1, u2, u3, u4, v1, v2, v3. Take anyone to be 0. So again, I am taking v3 be 0 initially. So that will give you direct values, that is 4, 3, 6, because their respective sums are here 0 plus 4 must be 4, 0 plus 3 is 3, and 0 plus 6 is 6. Okay, now since this is 4, this is 3, so here it must be minus 1. Now since here it is minus 1, here it is, okay, now here it is 6, here also it is 6, so here this quantity must be 0. And since this is 0, here this quantity must be 3. Now we think about the additional transportation cost. So additional transportation cost is here 9 plus 0 plus 4. 9 minus 0 plus 4. So 4, so 9 minus 4, it is 5. Here it is 8 minus 0 plus 3. So it is 3, so 8 minus 3, so again it is 5. Here it is 4 minus 1 plus 3. So it is 2, so 4 minus 2, so it is 2. Here it is 2 minus 1 plus 3. So minus 1 plus 3. So it is minus 1 plus 3 is 2. So 2 minus 2. So here it is 0. Here it is 1. So see 1 minus 1 plus 6. So minus 1 plus 6 is 5. So 1 minus 5. So it is minus 4. Here you are having 9. So 0 times 3. So 0 times 3. So 0 plus 3. It is 3. 9 minus 3. So it is 6. So only negative quantity is here. So find out the loop is whatever is possible there. So here loop is from here to here, here to here, here to here, and come back. So what are the positive corners? This and this is your positive corner. And what are the negative one? So this and this is your negative corner. So minimum from the negative corner is 200. So we will allocate 200 units from there. So our next allocations will be here 400 is as it is. So I am writing there it as it is. Here 300 is also as it is. So I am writing that as it is. Here I am transporting 200 units. So I am writing 200 units here. So here 200 units will be cancelled. So I am not writing anything there. Here I have added 200 units. So here it will be 250 now. And here 200 units is subtracted, that is 200 units left. 350 is as it is, so I am keeping that as it is. Again, you have to think about the UIs and VJs. So U1, U2, U3, U4, V1, V2, and V3. So take anyone to be 0, let U1 be 0. So if u1 is 0, your v1 is equals to 3. If v1 is 3 and to make u4 this sum be 6, so here you may have to take 3. If you are taking here 3s and to make this entry 1, you have to take here minus 2. Then since this is minus 2, here it is 3, so here you have to take 5. Then only this sum will be 3. And since this is 5, to make this entry 4, you have to take minus 1. This is minus 1, okay. And since this is minus 1, here it is 3, so to make this it is you have to take here 4. Now all ui and vj's are known, so find out the additional transportation cost. Here additional transportation cost is 9 minus 3 plus 5, so 8. 9 minus 8, it is 1. Here 8, so 8 minus 3 plus 4, so it is 7. So 8 minus 7, so it is 1. Here it is 4 minus 2 minus 2 plus 0. So it is 4 minus 2, it is 6. Here it is 2 minus 2 plus 4. So minus 2 plus 4 is 2. 2 plus 2 minus 2, it is 0. Here it is 9. So 9 minus 1 plus 0. Minus 1, it is 9 minus minus 1, it is plus 1. So 10, 9 plus 1, it is 10. Here it is 6. So 3, 6 minus minus 1 plus 3. So it is 2. So 6 minus 2, it is 4. So here, this all additional transportation costs are greater than or equal to 0. So this is an optimal solution. Okay, you now find out the final transportation cost. Transportation cost, you know that how to evaluate that. That is 3 times 400 plus 3 times 200 plus 4 times 250 plus 3 times 350 plus 1 times 200 plus 300 times 6. Okay, so that is your additional final optimal transportation cost. Yes. So we are stopping our session today, and you try such similar problems at home. Stay at home, stay safe. I will continue to the finding alternate solution from this solution in next upcoming lecture. Thank you.